All right, hello everybody. Thank you everybody, thank you. Yes. So, I'm gonna talk about building desktop applications with Electron. Who cares about this subject? Ah, all right, very nice. So, what we're going to go through today, it's a lot of ground. I hope I'll be fast enough. So first off, we'll take a look at what Electron is, the basic concepts. We'll go through a hello world, a very simple application. Then we'll talk about how to handle your assets in the Electron application, how to do databases, packaging, automatic updates, and then we'll see a case study. So an Electron application in practice. So Electron was made by GitHub. They made it in their effort to create their editor, Atom, and it was a great gift to the community as it has dramatically simplified the process of creating native desktop applications. So it does that, and it does that by using JavaScript and Node.js. So the executables that Electron can produce will work for Windows, OS X, and Linux, so pretty much everything is covered. And some of the features, highlights of the features are automatic updates, which is an awesomely cool module. It abstracts away from you all the burden of building such a system. It has cross-reporting, which doesn't work. Well, it works, but yeah, I don't know what to do with it. Native menu controls, so you can have native UI and UX for your application. Native notifications, you build into the desktop notification system directly. And you have specific components adjusted per operating system. So imagine like controlling the behavior of the dock on OS X, the dock icon of your application. And you have simplified IPC communication, which is also a burden, and we'll see how we will use that right after we check out the overview. So a lot of companies have embraced Electron. As you can see here, out of the highlights are Slack, the Atom editor, right? And if you recognize Wire, the failed chat app, and many more. I mean, I just had to crop them. So, yeah, my keywords.
Is the app failed because of Electron?
No, it's a marketing product, everything. All right. So, to understand Electron, we need to understand the basic concepts. All right. We have two kinds of processes. We have the main process, which basically is our Node.js application, the backend. Okay, that is called the main process. And we have the renderer process. The renderer process is the Chrome instance that runs and renders our views. So you can imagine that as your front end, the browser, but you have a specific browser target, and that is very important. So Chromium is 49, latest. Node.js is on the, how do we call this, the beta channel of Node? The experimental, the unstable one, but the 1.1 is stable. Electron boots through Node. And this is a very important detail, and it's a very big difference compared to Node WebKit, if you have heard of it, which is what we used to have before we had Electron. So Node WebKit promises you that you are going to have desktop native applications, but the point of entry for the Node WebKit is a browser view, which makes a big difference in the kind of applications that you can build, which means you are forced to render a view so you can have an application. Whereas with Electron, you do not need to have a rendered view for your application to function. This is very important if you're doing stuff like what we did, which is a server that runs on the background. And more on top of that, they have hacked Chromium, so you have the Node.js bindings on the renderer process. So imagine like on the front-end part, you can access the file system, you can access all low-level Node.js APIs directly from your front-end. So let's see a simple hello world application. This is the basic structure. This is the minimum required files for an Electron application to work. We need our package JSON. The package JSON needs to have at least those attributes and mainly just point to where the main file is. And the main file is our bootstrap file for our Electron application. It's the Node.js part. And then we have index.html, which is the view. And it's the HTML as you know it, nothing more, nothing less. Well, there are more. And through the HTML, you can then include your style sheets, your JavaScript files, your assets, everything. The way you start your Electron application is by typing npm start. And that's a requirement because an Electron application requires the Electron stack in order to operate, and npm start guarantees that this will happen for you. So too much code here. The idea, what I wanted to show you is just for you to get a taste of what's going on. You have the app instance, which is the electron.app, and then you listen on events on that instance. You listen for the ready event, and when that event triggers, you're ready to do your stuff and boot up the application. And you have many other events to control the behavior of your application, if it closed, if all the windows were closed, and act accordingly. So let's talk about assets. And by assets, again, we mean all the static files that are required for your front-end application to function, okay? Images, style sheets, JavaScript files, fonts, all of those are assets. So assets, you can put them wherever you want, wherever it makes sense to you as files. And we reference them based on their file system location. And this is different from a URL location, all right? We cannot have an absolute path starting by slash because slash refers to the root of our hard disk. So you either go with relative paths or you use direct paths, which the direct path of where the asset is, you can get it from Electron by asking it, what is my data folder? And it will return it for you, and then you can concatenate and directly require whatever asset you need to require. And this is in your markup, in your HTML code, all right? JavaScript has CommonJS built in, all right? Like we talked about before, they have hacked Chromium, and you have all the Node.js commands, well, most of them available to the front end. And as a result, we have the CommonJS system built in. So that means that you do not have to browserify your front-end assets. You may do so if you choose, but it's not required. And of course, we have a single target browser, okay? No more browser compatibilities. It's a single browser, single version, single target. if it works on your PC, it will work everywhere. So, binary assets. These are kind of different assets. They are not the assets as in that they will be used by your front-end part of the application. Those are binaries that your application needs to execute. So imagine like a Mongo database, if you bundle it all together in the application, or a custom command, whatever it may be. Again, those you position wherever you want in your application. You reference them, again, based on file system. A good suggestion would be to sub-module them, not have them tracked in your working repository, because they tend to be very large, and if you update the versions, they can explode the size of your repository. And you need to have all the targets that you are going to build the application for, okay? So there are different platforms, OS X, Windows, and there are different architectures, 32-bit, 64-bit, and you need to have it statically compiled, which includes in the binary all the libraries that are required for that binary to operate versus relying on whatever the system has. And that brings an even more burden in the size of the binary.
So you have to ship your application to both OS X, Linux, and Windows. You have to bundle all the binaries for all these.
You have to bundle whatever binaries your application needs to execute, and if it does, nobody does that typically. I'm just saying that in case you do, for example, we use FMPEG, so we have to bundle that binary, right?
Wouldn't be an option to just detect the platform during runtime and then just dynamically fetch the corresponding thing?
Yeah, that's also a solution.
Instead of just bundling the
Question
whole thing.
is, can you rely on that?
I don't know, I'm just asking if it's...
Yeah, it's within the realm of possibilities, but then again, you don't know, you have to take certain measures so as to protect the installation will work, somebody downloads your self-installable, shuts down the internet and goes on to install it.
Yeah.
Boom. So,
But with that logic, you should bundle everything your application needs.
of course you do.
So if it needs a massive, big dependency, you can bundle that too.
Yes, you bundle all your node modules. There you go. We're going to talk about this a little bit later on the packaging side. It's very dark there, I don't see.
Where do you compile? Can you compile to the same machine?
No.
Or you need to compile
No.
to each different system?
Of course,
for
you
each
need to compile for each different system, but typically you just, I don't know, depending on the case, all right? For FFmpeg, I just go to the website and it says statically compiled for OS X, statically compiled for Windows. I just download the binaries. I don't download the source and build it,
Okay, so when you will build something for Windows 32, will you need access to a Windows 32 thing?
Yes, you will need when you're packaging your application, when you're creating the executable.
Okay, you will need them.
Yes. And delete is not required on the build stage, and we are going to talk about the build stage in depth in the packaging section of our presentation, so no need to stay here any longer. Yeah, and to answer your question, NPM modules, you need to bundle them all. And the thing with NPM modules is that some of them have what we call native bindings. So they have C source code, which they compile on the fly, and that binary produced is binded to the system, all right? And those local bindings, when you're distributing an application, they need to be rewired so as to use the headers used by the specific node that executable that Electron uses. But the good news is that you don't have to worry about that at all, because the packaging automation does that for you transparently, so one less thing to be concerned about. Now, if you need to protect the source code, that is also possible. By default, the source code of the application, the whole directory that you have packaged, the node modules, the assets, the front-end code, everything is available as plain source code included within the package distributable that you're going to create. But this can change. Electron offers a solution named ASAR, which stands for Atom Shell Archive. And what ASAR does is that it's basically a tar archive. It will get all of your files, put them in a single binary file, and have an index so as to easily and fast access whatever file is required within that bundle. And in that fashion, you are in effect protecting your source code from pry eyes, at least from the amateurs. In order to roll out ASAR, you have to take special provisions throughout your code. So because everything is bundled in a single binary, first off, everything is read-only as far as your application is concerned. And then when you need to access certain files directly using the file system specific native functions of Node, you have to do it in a specific way so as to have the ASAR archive in between, which is going to fetch what you need and get it back to you.
So it's not something you can do in an instant. You code one way and you use ASAR to archive it.
Right, yeah. In our case, which we're going to see in the end, in our case study, we were not yet able to apply the ASAR because of the many ways we access the file system, but it's a big task in our backlog.
Mm-hmm.
Now, let's talk about application data. Application data is where your application stores its data, okay? It's different from where your application is. Your application is wherever it was installed into. So for OS X, it's in /applications, your app's name. That's where your app is. The application data is in the application data folder. Depending on the operating system, it's in different directories. And so for OS X, for instance, it's in your home directory, library, application support, /application name, and from then on you can create as many files you want, you can do anything. That is where you're supposed to write your files. Now let's take a look at databases, what options you have, what you can do. So first off, since we have a stable target, Chrome 49, we have session local storage and IndexedDB supported, and they're going to work. Don't worry, about maybe it's not supported somewhere or anywhere or different behaviors between browsers. None of that exists. Those are valid data storage services for you, and they're guaranteed to work. Now, if you want something more, especially because all of those services are on the renderer process, which is your front end, and you might need a data store on the back end. A solution is SQLite, which has been recompiled to JavaScript through Asm.js, etc. So you can directly require it as a module and have SQLite. SQLite uses a single file to store its data, so you're done. But if you need more complex stuff, or if you have legacy, like in our case, you can also bundle whatever database you love, okay? Redis, Mongo, Postgres, whatever. Of course, then again, you have the performance hit of the size of your self-installable and distributable. Now, let's talk about packaging. Packaging is the process where you take your source code and you generate the distributable. There are 5 steps in doing that, and figuring out those 5 steps took a lot of time for me. It was not very obvious from the start. So step number 1 is finalize your application, build whatever you need to build, preprocessors, SAS, whatever you do it, and bring your application into a final state. Then what you need to do is copy your whole application directory into another folder, namely, I name it build, whatever. And then as you have that copy, start chopping down whatever is not needed to be included in the package. Okay, so your test folders, dev dependencies in NPM, you do NPM prone, documentation, whatever you might have excessive in your repository, the source files that you have built into bundled files, okay, style sheets, SAS sources, whatever. And then on top of that, you might run some globule, I think it's a word, patterns on the file system on your Node modules that have remained, that are the production ones, so as to catch and possibly delete any unnecessary folders like testing folders, license. There's a whole pattern file that we have created. Margarita's helped me get started with that, and it's available to you if you need it. Where you go through every Node module and you delete whatever file is not necessary for your application to function. After that is done and you have the ready-made application product, you then run the Electron packager, which is an awesome library. Actually, it's created by Max Ogden. If you know him, he's a very famous open source author. And what the application packager, the Electron packager does, it does a lot of things. It takes care of the native bindings of the Node modules, so it rebuilds your Node modules for you. And it constructs the executable. Imagine it like, you know, on OS X, there is the app, the application name .app is what you launch. And what that basically is a directory inside, and packager creates all of that content for you, and it creates the executable. So now you have your executable, and what you need to do is create the self-installable, the final file that you're going to distribute, right? Which is, in the OS X case, it's the pkg. I think in Windows it's can be an exe or something else, I don't remember. So to do that, you need to run the appdmg package. Now, let's dive into Electron packager a little bit, because it does so many things, and it will help us understand better how this whole thing works. So Electron packager has a very simple setup, really easy, and it has both grunt and gulp tasks if you want to get started, but I suggest that you create your own grunt task if it's grunt you want to use, or JS module that directly accesses the Node API that the packager exposes. As I said, it automatically builds the NPM module, so you don't have to worry about that, and produces executables for all operating systems. This is the part, where's Margarita? Hiding. This is the part where you need to build, if you want to build the Windows executable, you need to build it on a Windows machine, okay? And also, yeah, manages code signing if you're on OS X. Yeah, it does all of those things. Automatic updates. Really simple implementation. You create your own UI UX. So it's just a system that runs on the background. And it requires a server HTTP API. That means that you need to create on your own server an endpoint that responds to clients, giving this response, which directs them to download the latest version from the specified URL, along with all the metadata, notes, and date. So the way auto-update works is that once you activate it on the client, and the way you activate it is by giving the URL of the endpoint of your server, it will check with the server and it will report the version that it is currently installed. The server takes that request and determines if an update is required based on the reported version from the client. If no update is required, then the server responds with no content. But if a response is required, if an update is required, then the server sends the response we saw in the previous slide, right here. If an update is required, the client will then proceed to download the update in the background without prompting, without asking anything. And once it's downloaded, it will automatically install it and wait for the next boot of the application to apply it. So the next time you start your application, you have the new version. Of course, there's an API call to force that, and that's up to you to prompt the user that a new version is available. Click here to restart and get it active right now. That's up to you to implement. So let's talk about the case study now, how this was applied to what I'm doing professionally. Now, a few words about Reveal. Reveal is instant replay for sports. So it's primarily used by coaches. The idea is that we shoot a video, and the video in real time goes through the server and distributed to all the clients available in the network, typically iPads, and there are some tagging functionalities, etc. We're going to see them very soon. And for that to happen, we have external cameras that are connected to encoding devices that stream the video to the server. The server reads those streams and creates the clips that are required for tagging etc. The whole thing, the whole service runs on a private network with custom hardware, Wi-Fi hardware. Everything is on battery in the stadium, and everything operates within a closed Wi-Fi network. The server is a Node.js server on a MacBook Air, and up to the point where we actually were scheduled to do the self-install thing, we were doing it manually. What we were actually shipping as a product was the MacBook Air to our customers, and they paid for that, imagine. So, yeah, and it's this is also a good lesson as engineers to always seek for the originating problem rather than the solution that is suggested to you. So your PM, your boss, whoever comes and tell you, we need to do X, Y, Z, all right? And it's quite possible that they have got it wrong, because you as an engineer is responsible for providing the solution, all right? You're not an engineer for doing what you're told. So what needs to happen is that you need to dig and drill down into the problem, understand it, and then you yourself need to provide the solution. So this is a very classic case of we need to do this setup, and we're going to work with NFS, and I was implementing, and by the moment I realized where this was used and why, the question of doing the self-install came up, and thus was scheduled to be implemented. But think of all the time we lost in between, right? So what we used up to the point where we went to Electron, we were on Node 0.12, and our server basically provided an HTTP and WebSockets API through Express, your pretty typical Node.js application. And we were using Redis and Mongo as our data stores. So the choice to migrate to Electron, of course, you understand, is a 90-degree turn on what we were doing. So we were doing a Node.js server for the cloud, and then we need to take all of that code base and put it within the Electron context. Total different things. So let's go through what happened for this to become a reality. Apparently it was easier than it sounded. The problem was this whole process took me about a month. 2 weeks out of that month was learning. So I was just staring at the monitor, trying to understand what the fuck was going on. And let me see. Right. So the way I chose to cut it was everything related to Electron went to the Electron folder. So Electron has its own backend, its own frontend. It's in Electron. So we have Electron front.js for the JavaScript files, etc. Redis had to go, and it had to go because our dependency to it wasn't strong. We only used it for a queuing library that we had that did queue management for us. So we had tasks that we generated, and we wanted them to be executed one by one. And we also use it for pub/sub. So pub/sub got replaced by the event emitter as far as the backend goes. And we created a very simple custom to the solution queuing mechanism to solve the other problem. And so Redis could get out of the stack. Mongo couldn't, and this is for a task for way down the road to migrate the whole code base to SQLite. But even that is not yet decided because it's a very big jump. So we had to use Mongo, and thus we are now bundling it in the binary. FmpEg code is bundled as well because we heavily depend on it. And then, booting work, rewiring everything, determining the paths, all of this stuff, boilerplate. This happened quickly, and it worked. It worked, unexpectedly easily. I mean, when we were planning this, we were planning like 3 months ahead. We're going to need to bring in a Windows installer specialist that knows how to create installers. Yeah, for OS X stuff, we had Thanos, and it was planned to be like 2-3 months project, and eventually, boom. Right, and let's do a demo.
So what's the file size came up with?
I'm going to show you everything right now. So let's start with here. So this is the working directory of the application. As you can see here, all the folders. Oops, no. Wrong project. Right, here we are. In the build folder, we have the output of the build of the packaging operation. So what we see here is the reveal app, which is the executable. If we see it through the Finder, we see that this is an executable. The size is 300 megabytes. But when we package it to DMG, it goes down to 100 megabytes. It's still large. We did our best to reduce the size. However, the binaries themselves are like 60% of the whole size here.
Okay, it's a regular.
Not really.
Some people are very critical of the
It's
size.
not like you're going to download.
I don't want to call them out.
You can download it.
So with npm start, we start the application. And it also launches the application itself.
So now the rest of the devices will connect to this server, right?
Yes, exactly. So
Mobiles and tablets and stuff.
yeah, This is actually a web URL you can also access. My IP address is .10.142. I'm not going to tell you. And
Where are you doing the customized IP address analysis?
what? The what?
Because they said with scope, I think.
Because we don't have the streaming app. And let me see. Right. So the idea here is that somebody shoots a video through the applications that we provide. They can also perform tagging while they're at it and upload their clip. And it's instantly available for them to review. Is that somebody shoots a video through the applications that we provide. Wow, big technology. Huge technology breakthrough. So yeah, that's all, folks. You have any questions? Now is the time.
Two things.
Yes.
You said that it was difficult, the part of the packaging and the building.
Yes.
It took some time to figure that out.
Yes.
Why?
Most of the time. Because there's no, the problem was all the documentation of Electron directs you to the packager, which produces the executable for you. Up to that point, we're perfect. Cool. The problem was creating the self-installable. And there was a problem because what I read was everybody was using a specific grunt package, which was really idiomatic in the way that it implemented everything. And
you didn't want to follow that way?
It was really screwed up. And the thing is that behind the scenes, what this package was using was the app.dmg package, which did what I wanted it to do. Take the binary, put it in DMG, boom, we're done. Everything else was, it was a nasty.
It surprised me because I was expecting that this would be straightforward and heavily documented, at least this part.
Yeah, well, they reach you up to the point where you have an executable. They don't take you down to or the suggestion that they make is a little misleading.
Second thing about Mongo. You said you're not sure yet, but you're considering migrate to SQLite.
Yeah.
Reasons?
Reasons to get rid of the Mongo dependency as a binary.
Just for the size.
Yes.
Not for a real technical reason. I mean, Mongo cannot give you what you need.
Yeah, to be more native friendly.
Okay.
So if you started today, you wouldn't put Mongo. We would, restrict ourselves within the limits of SQLite.
So the purposes of your application would have been totally covered with SQLite.
I don't want to answer that.
Speed?
Because I have to think about it right now.
Have you considered speed issues?
No, we are a local application. We're a local
files, no?
We're a local application. We don't have.
You have 2 requests per minute, Margaritis.
Okay, that's
not 2 million per second. It's different.
Okay, Theodoridis.
All right.
Bravo.
Cool, thank you. We now have the after party right here. There are beers in the refrigerator. We have
another question.
We have another question. Hold on, please. No more. Okay. What?
When you need the extra stuff from the dependencies, do you also need the tests from the node modules?
Yes, everything.
Bravo.